大家好，我是 Olive Branch 的 Alan. So today we're going to talk about sugar and why you've been hearing that sugar is so bad for you all the time. I'm going to unpack everything for you so you have a good understanding and why you should stay away from it. So the first thing you want to understand about sugar is all the different types of names there are for sugar. You might have heard of carbohydrates or why everyone's eating a low carb diet now or they stay away from sugar. Well, colloquially, sugar and carbohydrate are used synonymously, meaning they use it interchangeably. There is a little bit more technical term, and sugar is sometimes known as table sugar, the white crystals that you put into your coffee. That's specifically called sucrose, and fructose is the sugar that you find in fruit. Glucose is the type of sugar you find in pastas and breads and crackers. And then there's all these other different types of sugar like galactose and lactose and maltose and dextrose. And all of these sugars, you don't really need to know them all right now. They're not really that interesting. What we'll really focus on today is just glucose. And fructose, I'll explain a bit later in a future video. So now that we're focusing on glucose isn't particularly sweet. As you know, when you're eating sliced bread or pasta or rice, it doesn't particularly taste sweet. However, it's a very important molecule of energy that we'll be explaining the whole biochemistry of it all so that you have a good understanding. And you have to bear with me. I know the science might get a little thick right now, but I'll try to explain it in a way that's interesting and simple and brief. So when you're eating any form of glucose, they also come in the form of starch, which just basically means a lot of glucose that's already compounded together. When you ingest it into your body, the glucose gets broken up into individual molecules that are now floating in your bloodstream. This is what's typically known as blood sugar level. And when that gets too high, your body has to capture them because too high can actually kill you. But your body is very well equipped to handling that, and that's your pancreas, the organ right here. It produces insulin. The insulin then can go out into your bloodstream and hold the glucose, and then you're safe. Okay, you can have lots of that in your bloodstream. You won't die immediately from it. Once you have the insulin and the glucose together, insulin is like the boat that carries the glucose. The glucose is the passenger, and it flows down your bloodstream like a river. So people with type 1 diabetes, that's a disease where their pancreas cannot create insulin. And so this is a very dangerous disease because when you have any bit of food with glucose in it, your blood sugar level will spike. And if there's no insulin to capture it, then they can die, which is why they have these insulin injections to give them insulin to hold the glucose. Okay, so you have the insulin and you have the glucose cargo that's floating around in your bloodstream. Well, where does it go? It can go on any cell in the body because all cells require energy and they use energy in the form of glucose. So it's actually used everywhere. Let's just take a muscle cell, for example. A muscle cell, which is represented by this little box, there's all the chemistry that happens to produce metabolism, which is converting glucose to energy. The first thing that the boats have to do is to deliver the cargo to the muscle cell. And that happens at the dock or the insulin receptor, which is the gateway for allowing the glucose to go into the muscle cell. Drop the cargo, and then the boats can continue on its way. So the insulin receptor allows the glucose now to flow into the muscle cell. And in the cytoplasm of the muscle cell is where you have lots of enzymes that act on the glucose that keeps transforming it into what will eventually become the end product, pyruvate, which is another molecule that now goes into the mitochondria, and that's part 2. So all the enzymes that have been acting on the glucose to produce pyruvate, that is known as the anaerobic metabolism, also known as glycolysis, turning glucose into a little bit of energy in the form of ATP, adenosine triphosphate, but not a lot, just about 4 units of energy. 2 of them actually gets used again to produce pyruvate. Okay. So the pyruvate molecule now enters into the mitochondria, which is the engine of the muscle cell. So now that the pyruvate enters the mitochondria, a huge series of reactions happen inside. That's called the Krebs cycle, which transforms the pyruvate into 32 units of ATP. So it's a big payload of energy. Although you can generate a lot of energy from that one pyruvate molecule, which comes from that one molecule of glucose, that process of churning out 32 ATP is quite slow. It's a cycle, but each time it accepts a pyruvate, that cycle is slow, but you get a big payload. So that whole process of turning out 32 ATP units from your mitochondria, that is known as the aerobic metabolism. So a lot of people who are focusing on aerobics, or they're thinking about doing cardio exercise, they're primarily focusing on this payload of ATP from their mitochondria. So thank you very much for listening to this video. I hope you found it useful. And again, if you have any questions or comments, please feel free to leave them below or follow me on my official WeChat account. Thank you very much. See you next time.